Here's a question about potential-based shaping. So here's the Q-Learning update rule given an experience state, action, reward, next state, modified to deal with shaping. So we update the Q value alpha, learning rate of the way, toward the reward plus the discounted value of the next state, but we also add in a shaping reward based on the state, action, reward, next state. And what Ng, Harada, and Russell show is that if we define the shaping reward by assigning every state this potential value, and it doesn't matter how we assign them, but we have some consistent way of assigning potential values to states, then the shaping reward that we use in this update here is to subtract off the potential of the state we just left and add a discounted version of the potential of the state that we're going to. And what they show is that using this kind of shaping reward doesn't change the optimal policy of the MDP. So even though we throw in this extra term, we add some reward in here, it doesn't change which action is the best in each state. But it can make it so that the Q function is easier to learn, and one particular shaping function that they suggest is very powerful would be if you somehow already had a solution to the MDP and you had the optimal Q function, the potential for some state S is the maximum Q value in that state. So imagine we have an MDP and we use this perfect shaping function that they talk about in the paper. And then we do our learning and we converge, our value function converges. And let's say Vs is the value function that we learn at convergence. Then what can we say about the sum over all states of the value function?